Hi everyone, in this video I'm going to show how to use the FTDI D2XX drivers. Those drivers support a few different communication protocols, and one of the fastest is the Synchronous 245 FIFO mode. And it's basically an 8-bit bus, and it's a very easy way to transfer a large amount of data between a computer and an FPGA or perhaps a microcontroller. And so here I have a Lattice MachXO2 development board on the right, and then on the left I have a FTDI UM232H development board. And I just have some rainbow wire jumpers connecting the two boards, and then I have this USB hub just kind of conveniently holding them together. So I'm going to cover basically the entire process in this video. We're going to go from finding the documentation and kind of highlighting some of the most important parts of that, installing the software to write the code, actually writing the code, and then at the very end I will also benchmark it. So we will transfer 1 gig of data between the FPGA and the computer and see how fast we're able to do that. And on my particular computer I'm able to get about 350 or 360 megabits per second, which for USB 2.0 is pretty good. There is some overhead in the USB protocol itself, so you're never going to get the theoretical like 450 megabits per second. All right, I'm currently traveling, so my Wi-Fi is not so good. Hopefully this will work out all right. I'm using an FTDI development board, so I'm going to go ahead and type in that model number, which was UM232H. First link is a PDF, which is actually good, but I'm going to go down to the FTDI product page so I can show you some more information. So if we go to the UM232H, we'll scroll down a little bit. Here we go. So it's this little development board here. One thing I should point out is, as you can see here, from the fact, or it may not be obvious, but from the factory, it has these kind of rounded pins that are intended for use with like a dip socket. And those actually don't work too well with like jumper wires. So I ended up desoldering the two headers, and I soldered on regular pin headers with like the rectangular pins you typically see. As we can see here, it gives you an overview of what the board supports. It has a link to the PDF datasheet, which is good. There's also two drivers you can use with it. There's VCP, which is the virtual COM port, and then there's D2XX, which is the one we're going to use, which supports the more advanced communication protocols. Let's go ahead and take a look at that datasheet for the development board. Basically, it tells you everything about the board. So you get the schematic, you get pinout. There's some information about how the power is wired, which I need to highlight if you're going to use this. Out of the box, if you try to use it, it won't actually work. In my case, I want to power the development board, the FTDI development board, from the USB bus. And to do that, you need to install two jumpers, one on this side and one on this side. And of course, there's other ways to wire up the board, so you can kind of look through the data sheet for more details if you like. So if we look at the bottom of the FTDI board, you can see I have two jumpers installed, right there and right there. Let's go back up to the page that had information on what pin does what. Here we go. This is probably the most important page, I guess you could say, of this data sheet. Now, if we go back to the D2XX drivers page, when you plug in your FTDI device, Windows will probably automatically install the drivers, which is good. But you still need to download the driver package from FTDI because it has files you need for software development, which are not installed by Windows Update automatically. So if we scroll down, in my case, I'm going to show how to do this in Windows 10 and 64-bit. So I'll click here. And if we open up this zip file, there's a variety of useful files here. FTD2XX.H is the main header file, which you'll need, of course, for any software you want to write to communicate with the D2XX protocol. And then the actual libraries are available either as static libraries or as dynamic libraries. So you can use either, they both work. In this demonstration, I'm going to use the static library. So it would be in here, and then I'm going to use 64-bit, and this is the file. So later on, I'll show how to copy this all into the Visual Studio project. Okay, So there's a lot of other useful information that we need to know. If we scroll up here, we can see there's a document section. And probably the most important one is going to be the D2XX Programmer's Guide. So if you go to Programming Guides, okay, D2XX Programmer's Guide. This file basically explains the entire API. So it goes into all of the details of every function. You're going to want to skim through this, at least read the first few parts. It explains how the drivers work, and all of the functions. So as you'll see later, we'll need to use this function to get information about every FTDI device attached to the computer. Anyway, so it keeps on going. I'm not going to bore you and read through everything here, but this is really important. You're going to want to look through this, especially when you have problems in your software, if you have bugs. Look through and make sure you understand what every function does and all of its return types and possible fault conditions. If we go back, we'll go back again. Application Notes has some very useful documents as well. Okay, if you scroll down to the AN232 section down below, there is a lot of very useful documents. AN232B-03, which is optimizing data throughput. This is going to cover some of the functions we need to call and some of the methods we need to kind of plan our software to get the best data transfer rate. So basically there's interactions between the USB transfer sizes you use and the latency settings you set up in the driver. It's a short document, so you probably want to read it all. It's only, a couple pages of text. AN232B04 covers more of that as well. Or actually, this is the one that covers the latency. But again, similar thing. It's a very short document. You'll want to kind of read through it if you care about getting the highest data transfer rate. It explains kind of why I'm going to be doing what I'm doing. So you'll want to skim through this later as well if you're curious. And if we go back and then go to the technical notes, TN153 is going to be a very useful document. It covers basically what I'm going to be showing in this video, or at least a majority of it. And it's basically how to use Visual Studio to communicate with the D2XX drivers. And it tells you how to set up the project. It's a little bit outdated. It's for, from several years ago. And if we go back again, let's see. Oh, there was another application note I forgot to mention. Let's go back to application notes again. AN130. AN130 is covering, again, it's basically covering what I'm going to be doing in this video. It's how to use the FT245 synchronous FIFO mode. And so I guess the three most important documents you need to do this project is this document, and the programmer's guide document, as well as, of course, the pinout for whatever device you're using. So let's go ahead and set up Visual Studio. I already have it set up on my computer, but I want to show you the entire process from start to end. So I'm actually going to do this in a virtual machine. You don't need to use a VM, but I will just so I can make sure that I show you everything from start to end. Okay, so here we are. I have just a Windows 10 VM. This is basically just a VM that I set up that has updates installed and Chrome. We're going to need Visual Studio. I'm traveling right now, so hopefully this Wi-Fi will be useful. Okay, so Visual Studio downloads. The community version is fine. Okay, so Visual Studio is available with a wide variety of, I guess you could say, plugins or features. The only one we need is the desktop development with C++. We're actually just going to be writing C, but the C++ version is fine. And then you click Install. All right, so Visual Studio is finally installed. I'm not going to create an account yet. Everything's fine. I'm going to pick the light theme, but that's not critical. Okay, actually, before I do the Visual Studio part, I should probably explain or set up a few more things. First of all, I'm going to go ahead and plug in my development boards so that we can make sure that the FTDI drivers are installed by Windows Update. So I'm going to go ahead and plug that in now. Okay, so again, because I'm using a VM, I have to make sure it connects to the VM and not to my host, which is fine, but you won't need to do this. Okay, so yeah, basically what I did, in case you're curious, the FTDI development board is this one, the UM232H, and then the Lattice one is the FTDI that's actually on the FPGA board. If anyone's curious, the FTDI on the FPGA board is actually more powerful, and it supports the FT245 synchronous FIFO mode. The only problem is the FTDI chip on the Lattice board actually has two ports, and you would think you could use one for FIFO and one for JTAG to program the chip. However, the way they laid out the circuit board, they're using port A for JTAG, and only port A supports the FIFO mode. So unfortunately, I can't use the FTDI that's built onto the development board. But that's kind of irrelevant for most of you guys. I'm just letting you know in case you happen to have that development board as well. If we go back to Windows, let's open up the device manager. You right click on Start, go to Device Manager, and we need to make sure the drivers are installed, and it looks like they are. So we don't have any like yellow triangle errors. So we should be good there. I should also kind of share the source code for the FPGA in case anybody is also using an FPGA to talk to the FTDI chip. Let me go ahead and open up Lattice Diamond. Okay, so this is a very, very basic program. And by the way, I'll have links in the video description with all the source code, so you don't have to try to read it off of the video. There'll be links to the code for both Visual Studio and Lattice Diamond, also links to the exact items I'm using, the two development boards, in case you're curious. Just to give you an overview of the signals, these are the signals going between the FPGA and the FTDI. There is an 8-bit bus, which I just call data, and I have it connecting to FPGA pins 1, 2, 3, 4, 9, 10, 11, and 12. There is a signal that we need to read called, or I call it receiver empty. I think the datasheet calls it something different, but I just give it a more, I guess, understandable name for me. Another signal called transmitter full. A output signal called read N, which is an active low read enable. Write N, which is an active low write enable. A send immediately N, which is an active low signal that can ask the FTDI to basically flush its buffers and send it to the computer. I'm not actually using that, but it's one of the signals. There is a clock which is driven by the FTDI and it controls the FPGA. Finally, there is a output enable active low pin. And then just to make my life easier, I decided to have two status LEDs, one which is just a power LED, which is always on, and one which is a transmitter active LED, which I light up whenever the FPGA is transferring data to the computer, or to the FTDI, to be more specific. Okay, so it's a very, very simple, I guess you could say, program. We have an 8-bit counter. On every rising edge of the clock coming from the FTDI, well, I turn on the power LED just because I have to do it somewhere. I enable the outputs because I am always, or I'm sorry, I'm disabling the outputs. It's active low and I'm driving it high. So I'm disabling the outputs because in this quick example, I am always writing data from the FPGA to the FTDI. I am never reading data. In other words, I'm never sending data from the computer to the FPGA. And then send immediately, I leave that high because again, it's active low and I don't need to use that signal, so leave it high. Okay, this is basically the bulk of the work right here. On every rising edge of the clock, if the transmit buffer on the FTDI is not full, that means it is able to receive another byte from the FPGA. So I tell it that I'm going to write by driving the active low write pin low. I copy the value of my 8-bit counter to the 8 data pins. I turn on the transmitter active LED just as a visual indicator, and then I increment my 8-bit counter. If the transmitter is full, then I stop writing. I change write to high because it's active low. Just for the sake of it, I also turn off reading because I'm not going to be reading, so I drive that high as well. And I turn off the transmitter active LED. So in other words, this is a very trivial example where the FPGA will send, you could say hex 00, and then 01, and then 02, 03, and so on all the way up to FF, and then it'll wrap around to 00, 01, 02, and so on. So I'm basically just transmitting a dummy stream of bytes to the computer, always incrementing every clock. So that's all there is to it. Very simple code. Doesn't take up much resources on your FPGA. Again, if you want to implement something more advanced, like if you're going to read and write, then you need to implement some more logic. But that's it for this demonstration. Now that you know kind of what the FPGA is doing, and we have the D2XX drivers installed because we checked that in Device Manager, I'm going to go ahead and open up Visual Studio again. Or actually, sorry. Since I'm doing this on the VM, I need to download that D2XX driver again. So I'm going to leave that here for now. Let's go ahead and open up Visual Studio. Create a new project. We can just go ahead and do an empty project, C++. That's perfectly fine. I'm going to call mine D2XX _ test. Let's put it on the desktop just to make it easy and obvious of where it is. And yeah, that's fine. Create. Like we chose, we decided to do an empty project, so there is nothing here. Let's go ahead and add a source file. So file, new file. And we'll go to Visual C++, C++ file, desktop, go here. I'm going to call it main. Why didn't that put it in there? Oh, I guess I probably should have done it instead of, yeah. So, okay, instead of doing file, new file, what I should have done is right-clicked over here and then do add new item. But I didn't. So I can fix that by telling Visual Studio it's part of the project. Okay. Just to make sure that the compiler installed and everything's working correctly, let's just do a really quick hello world. We'll go ahead and save it and try running it. So now we know that it worked. I just wanted to verify the compiler is working. Okay, good. So now we can actually write the D2XX program. We're going to need to, okay, so if we go back to the zip file from FTDI, we're going to need to copy some files into our Visual Studio project. One of them is the FTDI2XX.H header file. I'll go ahead and just drag and drop it there. I'm going to use the static version of the library. You can either use static or dynamic. Static is a little bit easier, so that's what I'm going to use. Go ahead and copy the .lib file into the project. There we go. And that's all we need from that zip file for now. Okay, so we need to tell Visual Studio about these two files because just because we copy them to the folder doesn't mean Visual Studio knows they exist. So I'm going to then, from the Visual Studio folder, drag it and drop the header file into header files. And the .lib file, I'll put it under resources. You can close that. Right-click on your project and go to Properties. Okay, here we go. Go to Configuration, All Configurations, Platform, All Platforms. Under Configuration Properties, go to C, C++, Preprocessor. Go to Preprocessor Definitions, click here and then click on the down arrow. Then go to Edit. Go ahead and type in this macro. So it's FTD2XX underscore static. Okay. And okay. So in case you're wondering why I did that, if we take a look at the header file, it's going to look to see if this is defined. If you leave it out, you'll get compiler errors or runtime errors. I forget which, but earlier I left it out and I had problems. This explains why and everything. So if you want more details, check out TN153. So I'm going to go ahead and start writing some of the source code. I'll explain it at the end. So like most C libraries, they give you a handle to the device because you don't have an object, you just have a reference to it or a handle. I'm not actually using the handle yet, but I will in a little bit. So I just declared that up at the top. The first thing we want to do is figure out how many FTDI devices are attached to the computer. And you call ft create device info list, and you give it a pointer to a unsigned long, and it will then put the number in your unsigned long. It will return a status code. In this case, we hope that we'll get an FTOK. If we don't, that's an error, and I just print out a error message and I exit the program. After we know how many devices there are, we can allocate some memory for a list of information about the devices. And so basically we call malloc and we tell it how many bytes we need, which is the number of devices times the size of the FT device list info node, which is a structure. If you control click, it'll take you to that part in FTD2XX.H. We can see that it has these fields. Anyway, so we cast the void pointer from malloc into a FT device list info node pointer, and we save that as device info. And we call get device info list, which will, we give it a pointer to that memory, a pointer to the number of devices, and again, it will populate that memory and then return FTOK on success or something else on error. And then after I get that list, I go ahead and I iterate through it, and I just print it out to the console. So let's make sure this works and see if the computer can find the FTDI devices attached to my computer. So I'll go ahead and save, and let's try compiling it. Well, that sucks. Okay, build errors. I guess I forgot to tell Visual Studio about the .lib file. Let's see. Right-click on the project, go to Properties. Okay, so again, make sure you have all configurations, all platforms. Go to Configuration Properties, Linker, Input, Additional Dependencies. And we want to type in FTD2XX.lib. And then OK. Let's see if that takes care of some of the problems. Oh, okay. So I guess it was defaulting to 32-bit, but we need to switch to 64-bit. Try again. There we go. And so that's why I like to do this all in a VM, because I would have not gotten some of those errors, because I think on mine I already had it set up for 64-bit. So yeah. Anyway, so we can see here we have 3 FTDI devices detected. The first device, device number 0, is port B on my Lattice development board. Device 1 is the Lattice, I guess, port A FTDI device, and that is used for JTAG to program the FPGA. And then device 2 is the device we care about. It is the UM232H development board. Location ID, I believe, is a unique identifier for the device. And the reason for that is when you open a device, you can open it by location or by serial number or by description. The problem is description is adjustable by the user, so it could be anything, and it's not guaranteed to be unique. Likewise, serial number is also adjustable by the user, so it is not guaranteed to be unique. Location ID would be unique. However, in the documentation FTDI provides, they say that it is not supported in Linux. So in Linux, you have to use the description or the serial number to open it. And then handle, I'm guessing it's actually a memory address, but in any case, it's whatever you use to reference the device. At this point in time, we have not opened any of these devices, so the handle will be 0 for all of them because we don't have a handle. And so that's good. Let me go back to the PDFs and I will explain a little bit. Go to Appendix A, type definitions. Okay, so this is kind of what some of those numbers mean. For starters, the FTOK that you saw earlier is one of the return codes. And if there's errors, you'll get one of the other ones. So, invalid handle, IO error, and so on. For flags, let's see. There's multiple definitions for flags, and I think, if I remember correct, the one that we care about indicates if it's already open and if it's high speed. I'm trying to figure out where that is. Oh, okay. Yeah, so it's actually the flags that we saw here. It's actually an enum, and there's two bits that are used. Bit 0 is indicating if the device is open, and bit 1 is indicating if the device is a USB high speed or a full speed device. So in this case, we see we have the flag is hex 2, which means that bit 1 is set, which means that it is not opened, and it is a USB high-speed device. High-speed being the, I believe, 450 megabits per second, roughly, and full speed is the lower, I think it's like 11 or 16 megabits per second. Okay, and then type is an enum of the type is going to be one of these devices. So type 6 would be 0, 1, 2, 3, 4, 5, 6, 2232H. And that is the FTDI chip on the Lattice board. And it is what I think FTDI calls it, I think it's a 2-port chip, where basically it's kind of like having two FTDIs on one chip. So it's actually, it enumerates as 2 different devices, which are here. And then type 8 is the 232H, which is going to be the FTDI on the FTDI breakout board that I have that we're actually using. Location ID is what I already mentioned. ID, that I don't remember. Okay, let's not waste more time. You can read through the D2XX Programmer's Guide for more information. What I'm going to do now is I'm going to connect to this device, and I'm going to try to transfer 1 gigabyte of data from the FPGA to the computer. And one of the ways to connect is by serial number, which is what I'll do. And I'm going to basically look through this list, and when I find the one that has this serial number, I'll try to connect to it and configure it. Okay, so let me explain what we've got so far. What I'm doing is when I loop through the list of information, when we get to the one that has this serial number, which is the development board I have right here, I try to open by that serial number. So I need to give it a pointer to that C string, which is right here. I need to tell it that I'm trying to open by serial number, and I need to give it a pointer to the handle, which is where it will give me the handle if it succeeded. And if it succeeded in opening, it will return FTOK. And I basically just have a whole bunch of logical ands here because I want all of these to succeed. And if one or more fails, I have a problem and I give up. I print an error and I exit. So after we open the device, we need to do set bit mode to FF and 40. And that is from the documentation from FTDI. So if you go to AN 130, okay, so here it talks about using set bit mode to mask and then OX40. In this case, mask would be FF because we want to configure every pin that way. The latency timer is set to 2. That's the lowest latency. USB parameters is we have a FIFO size. I believe it's transmit and receive. Yeah, in and out, yeah. And basically we want to use the largest buffer size, which is 64K, which is 65536 bytes. We set flow control to flow RTS and CTS, and that is from one of the application notes. So if we go to AN130, oh yeah, we're already on AN130. They talk about it right here. I'm guessing that's an issue in the driver, but they tell you to do it, and I'm going to go ahead and trust them to do it, and go ahead and do it. We then flush the FIFOs because we don't want any junk that might still be in there. So I empty the receiver FIFO and the transmit FIFO, and then I set timeouts so that when I read or write, it will give up after 1 second or 1,000 milliseconds if it isn't able to send or receive the requested amount of data. So before I go ahead and transfer the data, let's make sure this actually works. So far, so we can close this now. Let's save, run it again. Unable to connect to or configure the device exiting. Okay, so I made a mistake somewhere. Did I get the serial number wrong? Oh, I think I forgot to make sure this returns FT. Okay. Yeah, that was the problem. Okay, so now that part of my code is fine. Okay, so we were able to connect to the device. Let's go ahead and try transferring 1 gigabyte of data and benchmark that, see how quickly it can transfer the data. Okay, so now we can go ahead and try to read 1 gig of data from the FPGA. So each transfer size is limited to 64K because that's how big the buffer is on the chip. And so what I have to do is I have to split up 1 gigabyte into 64K times 16K. So if we open up the calculator, and that is your 1 gig of data. And again, 1 gig isn't 1 billion. It's because of powers of 2. Here, open up another calculator. Let's verify I did the math right. So we do 2 times 2. Oh, I got that wrong. Okay, so it should be 16,384. Oops, I typed that wrong from my notes. There we go, 16,384. So we need to do 16,384 reads, and each read is 64K bytes. And what I do is I record the start time and the stop time, and we can convert that into a number of seconds by looking at the delta and dividing by clocks per second. And then we can convert the number of seconds into, or we can factor in the number of seconds to calculate the megabits per second by using this number. So again, if we go to So that is 1 gigabyte, but we want gigabits, which is multiplied by 8. And we can see that, well, that's the number of bits in a gigabit. We want to convert that into megabits, so we want to divide by 1 million. So you have 8589 and then 0.934592. Okay, let's go ahead and run the program. Oh, okay. So I forgot to put brackets around here. So that was the problem that we had. The two warnings are actually fine. It's because, FT handle is, I guess you could say, I think it's a pointer. Let's see. Yeah, it's a void pointer. So it's complaining because we're giving it a void pointer, but we're printing out as if it was a number. In this case, that's what I want. So those warnings are fine. I could cast to get rid of them, but who cares? Anyway, let's try again. Okay, so now it is actually doing the transfer. It'll take a little bit, and we'll see what the results are. All right, there we go. So we can see that I read 1 gig of data from the FTDI. It took 24.2 seconds. If you do the math, it works out to 355.6 megabits per second. And that's in this VM. When I run it on my computer outside the VM, I get about 359, so just slightly better. In any case, this is pretty good for USB 2.0. Keep in mind, however, that this is being done with an FPGA that is always able to send data. So of course, if the thing sending data to the FTDI is slow and it can't keep up, then you're limited there. And also the USB bus. So if you have, for example, like a USB 2.0 hard drive or memory stick on the same bus and you're transferring data, that will slow down your transfers as well. Anyway, this is kind of a good starting point. I hope this video was helpful. The documents that I mentioned earlier will be really helpful. You'll want to look through the programmer's guide. So I didn't cover everything because I want to make this video relatively quick. But for example, we didn't even bother closing the device because it'll automatically be closed when you exit the program. But of course, if you're doing something beyond this trivial demonstration, you want to close the device, do everything the proper way. But yeah, this document's really important. It kind of covers all the details, what everything means, what all the errors are. If you have any questions or comments, leave them down below. Again, I will have links to the source code and all these PDFs and everything, and the development boards and items that I'm using. I'll have that all in the video description, so you can check them out if you want, instead of reading off of the video, which can be a pain, I understand. Anyway, if you have any questions or comments, leave them down below, and I hope the video was helpful. If you know anybody that might benefit from the video, please share a link.